So let's break down isomers. Okay, so isomers, there's two types. There are structural isomers, or so-called constitutional isomers, or stereoisomers. Now, structural isomers, they're fairly easier. So structural isomers. They have the exact same molecular formula, but how they differ is within how the compound is arranged. So if you have, let's say, a hexane, 1, 2, 3, 4, 5, 6, you have our hexane, okay, and then you have 1, 2, 3, 4, 5, 6. Okay, so you have our 1, 2, 3 methyl pentane. So this is the exact same molecular formula as this. However, this is still different because the connectivity of the atoms is different. Here we have a pentane, methyl group here, whereas here we have a long chain of hexane. So these are structural isomers. Now another one, which is called stereoisomers. Now stereoisomers also have the exact same molecular formula, but their connectivity is slightly different. How it works is the arrangement is different. So for stereoisomers, there are two types, two main important types. One is enantiomers, and then the other one is diastereomers. Diastereomers. Okay, so enantiomers are exactly what you say is mirror images. So let's say, okay, let's talk about stereoisomers first. So stereoisomers, we know that the molecular formula is the same, the connections are the same, they're made up of the exact same things, same constituents, but the 3D conformation is different. So stereoisomers is a reflection. Here we saw structural isomers. It's not a reflection. If you were to draw, a mirror image, I mean, if you draw a mirror right here, this is not the same exact reflection. So stereoisomers, there is a reflection in one way or the other. So let's just look at enantiomers right now, okay? So enantiomers are mirror images, which is the exact same as the original. So if you look at one example, let me draw this out. It says carbon, chlorine, okay, so we have this compound. So we know that this is going into the page. It's going out of the page. This is going into the page. Okay, so the chlorine is coming out at us, and the hydrogen is going behind. So if I was to draw a mirror, okay, imagine this is a mirror. Then if you were to take this and flip it, if it's an enantiomer, then you will get the exact same thing. So that means that if you were to flip this, you would get your CH3 right here. Now remember, this is coming out, so if you were to flip it, this is going to go behind. So now the bromine is going to go behind, and our hydrogen is going to come out. Okay? And same thing here. Our chlorine is coming out, so now it's going to go behind because you're switching it. So our chlorine is going to go behind, and our hydrogen is going to come out. So this is our enantiomer right here. This is an enantiomer because it's an exact mirror image of the original compound, and we have an exact mirror image right here. Also, one more thing. is this carbon right here and this carbon right here is called a chiral carbon. So this right here, these carbons right here, they're called chiral carbon. Chiral means that this carbon has 4 different substituents. So this is a different group, this is a different group, or this is a different atom, different group, different atom, and different group, right? So 4 different atoms means that this carbon is chiral. It's just something important to know. So now let's look at diastereomers, okay? Let's look at diastereomers. So diastereomers, we have another example, would be, let's say CH3 Br. And then, so this is diastereomer. Let's imagine we have a mirror image here, okay? However, since this is a diastereomer, it's not going to have a mirror image. So in this case, let's just look at this one. Okay, so here you see that if there was a mirror right here, right, and if you were to flip this one, this compound, you were to flip it, you would get bromine on this side, you would get hydrogen on this side. So this part is correct. It's the exact opposite, okay? However, if you look at this, chlorine, it didn't swap. Chlorine is supposed to be here, but since it's not, that means that it's not a mirror image. So this is the reason why this is a diastereomer. So this compound is a diastereomer. And that's pretty much the only difference. And then just remember that the chiral carbon is a carbon where the carbon is bonded to 4 different groups. So 1, 2, 3, 4 different groups. So that's why this is a chiral carbon. But other than that, this is pretty much it for diastereomers, enantiomers, which are part of the stereoisomers. And then we have structural isomers, also known as constitutional isomers, which means that they're the same molecular formula but different arrangements.